right. Welcome back. So we are continuing our conversation about scientific numbers. And today we're going to talk about significant figures, what they are and how we count them. So in chemistry and all science, we use instruments to measure data, to measure values so that we can better understand the world that we live in. Those instruments that we use intrinsically have a limit to how certain they can be. Their uncertainty of the device, it's built in to any device. We need to record and preserve how accurately we collected that data so that not only telling somebody how much something is, but how well we can be certain of that value. That idea are called the significance of the figures or significant figures, and it's how we preserve that certainty that comes from the instrument that we used to measure the value. So, and I'm sure that there's more conversations that you'll have in class about significant figures, but what we want to know today is how do we count them and how do they change or not change when we do math. So first, let's talk about how we count them. Here are the rules for what makes a significant figure. Anything that's not zero as a digit is going to be significant. We know that that's not an assumed or rounded value. Interior zeros, zeros between two non-zero digits, like 101, that middle zero is significant by its placement. When a decimal point is present, and that's very important, any zeros that trail after a decimal point are significant. They're there for a reason. Trailing zeros before a decimal point, but with the decimal point zero, something like 100.00, those trailing zeros that happen before the decimal point are significant. The only zeros, the only thing for that matter, that's not significant are leading zeros. So a lot of 5 different rules to really say that the one thing that aren't significant are leading zeros. So maybe more importantly, how do we determine how many significant figures if we're given a value? 3 steps. The first step is easy. Make sure that the measurement has a decimal point. A decimal point is a way scientists say that this value has been measured and being reported with significance. Obviously, there's other purposes for a decimal point, but one of the ways that we can use them is to say that this value we know has significance being reported with it. Then we're going to start at the left of the number, and we're going to move every digit to the right until we reach our first non-zero digit. That's where we'll start. We'll start there and we'll count every digit to the right of that first digit as significant, including all zeros between non-zero digits. So let's see how that works. But before we do that, not all numbers are created equal. Remember, we're talking about numbers that come from instruments with uncertainty, and we're trying to continue the knowledge of that uncertainty through our calculations of our measurements. But something like 21 books is not measured with a ruler or a balance. This is an exact number without some number of significance to it based on the instrument that measured it, our eyes, our brain. We would say this has infinite significant figures, and this will come into play later when we're deciding which has more significant figures or less. When something has an exact number, we'll say that it has unlimited significant figures. So when you want to find the radius and you take the diameter divided by 2, the diameter might be a length that we measure with some uncertainty, but when we divide by 2, that 2 does not have one significant figure. It has infinite significant figures, unlimited significant figures. Or a relationship like 100 centimeters is 1 meter. That's an exact relationship. We don't say that this has 1 or 3 significant figures. We say that these numbers have infinite significant figures. Their values do not come from a measurement, but from a relationship that we're not concerned with how it was measured in this case. So let's use these 3 rules to find how many significant figures are in this value here. So we're going to make sure that the number has a decimal point. We're going to start at the left side and move right until we reach the first non-zero digit. That's here, this 1. And then we're going to continue to move from left to right and count every other digit, including interior 0. So 1, 2, 3, 4. So how many significants in this measurement? There are 4 significant figures. We'll call them sig figs. 4 sig figs. Let's try another. Okay, 1.2500 times 10 to the 4th meters. So we have some scientific notation here. The great thing about scientific notation, it comes with a decimal point, which is our first rule to ensure there's a decimal point. And it's because it's a number between 1 and 10, the first number that we start with is usually the first number. Start at the left, first non-zero digit, that's 1, and count every digit, including trailing zeros, such as these, if they come after the decimal point. The only time we don't count the zeros are when they're leading zeros. And so we have 1, 2, 3, 4, 5, 6. The significant figures come here from the decimal point of the scientific notation. These numbers here are exact. These are exact numbers, and they're just talking about what we have to do to these significant figures to scale them by orders of 10, either up or down, to get to our final number, but they do not carry significance. Here is where we carry the significant figures, and there are 6 significant figures in this value. So although we see a 4 and we see a 10, we don't count these. We just count and report our significant figures in the decimal point of the scientific notation. All right, let's try another. So here we have a value, decimal point. That's the first step. Check. So start at the left and move right until we find our first non-zero digit. Got a long way to go. And we go here. And then we have 1, 2. So 2 significant figures. I mentioned that scientific notation is a nice way to see significant figures. Let me demonstrate why that is. Let's take this value and convert it to scientific notation. We would need a number, and if you aren't sure about how I'm doing that, of course, this isn't part of this conversation, but there is a video help that can show you how to get to scientific notation. We'll need a number between 1 and 10, so that would be 1.3 times 10 to the 1, 2, 3, 4, 5, 6 in the negative direction, 6 kilograms. So this is how we would rewrite the number in scientific notation, and take a look at what happens. Do the same significant figure calculation. Start to the left, make sure there's a decimal point, start to the left, count every digit, 1, 2, 2 significant figures. So in the conversion between decimal notation and scientific notation, the number of significant figures, if done correctly, does not change, and they always come from the decimal place here of the scientific notation or trailing here in the decimal notation. All right, I digress. Let's try another example. Here's a big one, 0.58903000 grams. So see if there's a decimal point, check. Start at the left and move to the right until we find our first non-zero digit, check. Then count every other digit until we reach the end. So 1, 2, 3, 4, 5, 6, 7, including interior zeros and trailing zeros. It's only the leading zeros that we drop, which we have according to our 3 rules. And so this should have 7 significant figures. The only one that's not significant in this value is here, in the first leading zero. 24 cars. So this is a little tricky one. First of all, a little hint, there's no decimal point, so that spins us for a little bit of a loop. And then we realize, what instrument would you be using to count 24 cars? Do you ever have 24.2 cars or 23.000 something cars? No, this is an exact number that doesn't reflect how well it was measured, how well the instrument that we measured it was certain on its value. It's a pretty finite number, the way that we count, an exact way. So this question we would say has infinite number of significant figures. And one more, this is a number reminiscent of something you might calculate in a chemistry lab, 24.00 milliliters. How many significant figures do we have with this measurement? Check that there's a decimal point. Yes, start at the left. Find the first non-zero digit, which is 2, and move to the right, counting every digit after, 1, 2, 3, 4. This 24.00 milliliters has 4 significant figures. Now, there is more rules to apply once we know how many significant figures that we're going to want to apply when we do math to numbers with significance. And there's another video that you can watch to learn more about that. But make sure that you get practice on the review assignment on how to count significant figures so you're ready to go for chemistry class.